So, to go over the answers to the questions from your textbook, number 28 asked about Henry Heavyweight weighs 1,200 newtons and stands on a pair of bathroom scales so that one scale reads twice as much as the other. So in this case, you've got 800 on one scale and 400 on the other. If you feel comfortable with basic algebra, you could solve it that way, or some people just actually see it, or otherwise you might have to do this one by trial and error. Number 29, the question is about the sketch showing the painter's scaffold in mechanical equilibrium. The person in the middle weighed 500 newtons and the tensions in each rope are 400 newtons. And it asks you what the weight of the scaffold is. So it's got 800 newtons up, 500 newtons down. And since it is in mechanical equilibrium, we know that the weight of the scaffold must be 300 newtons. Number 30, a different scaffold that weighs 400 newtons supports two painters, one 500 newtons, one 400 newtons, and the reading in the left-hand scale is 800. So what is the reading in the right-hand scale? So we have a downward of 500 plus 400 plus 400, which would be 1,300. And upwards, we have 800 newtons. So on the right-hand side, what's left is 500 newtons. Then 33B, we're going to rank the support force the table exerts on these objects from greatest to least. So the one with the largest mass is going to have the largest normal force. So we're going to have these in order of B, A, C, and D. So the next question we had was number 70. So number 70 asked, as you stand on a floor, does the floor exert an upward force against your feet? And how much force does it exert? Why aren't you moved upward by this force? Well, when you stand on the floor pushes upward against your feet with a force equal to that of your weight. And this upward force is the normal force, and your weight are oppositely directed. And since they both act on the same body U, they cancel to produce a net force of 0. So that means that you're not accelerated and you're not set into motion. Number 73. If you pull horizontally on a crate with a force of 200 newtons, it slides across the floor in dynamic equilibrium. How much friction is acting on the crate? Well, it has to be 200 newtons opposite to the 200 Newton pull that you gave the crate. And then number 88. Before the time of Galileo and Newton, some learned scholars thought that a stone dropped from the top of a tall mast of a moving ship would fall vertically and hit the deck behind the mast at a distance equal to how far the ship had moved forward while the stone was falling. In light of your understanding of Newton's first law, what do you think? So the stone will fall vertically if released from rest. If the stone is dropped from the top of the mast of a moving ship, the horizontal motion is not changed when the stone is dropped, providing air resistance is negligible and the ship's motion is steady and straight. So from the frame of reference of the moving ship, the stone falls in a vertical straight line path, landing right at the base of the mast. So I have one other thing. I'd like to go back to where we started this chapter with this page 6, where you were looking at some preconceived notions that you might have had about forces and motion. So I want to go back now and take a look at them. Now that we've studied quite a bit about forces and motion, let's take another look at these and see how you did. So number 1, a force is required to keep an object moving in a given direction. Well, hopefully you realize at this point in time that's false. Number 2, an upward moving object must be experienced, or at least usually does experience, an upward force. Well, nope, just because it's moving upward doesn't mean that there's any forces acting on it. Number 3, a rightward moving object must be experiencing, or at least usually does experience, a rightward force. Nope, you don't. Just because it's moving to the right doesn't mean it has to have any forces pushing it to the right at that point in time. Number 4, a ball is moving upwards and rightwards towards its peak. The ball experiences a force that is directed upwards and rightwards. Nope, still same concept. Number 5, if a person throws a ball with his hand then the force of the hand upon the ball is experienced by the ball for at least a little while after the ball leaves the hand. Well, no, if a force is a push or a pull, it can't be exerting a force anymore once they're no longer touching. You can't push or pull something that you're not touching unless you have some magical powers. Number 6, a cannonball is shot from a cannon at a very high speed. The force of the explosion will be experienced by the cannonball for several seconds, or at least for a little while. Again, no, that force, they have to be in contact in order for the force to be experienced by the cannonball. And number 7, if an object is at rest, then there are no forces acting upon the object. No, because there's still weight, because especially here on Earth, we always have weight acting on all of the objects as well as us. So hopefully, whether you got these all right when you first did this paper, you understand all of these now. So I'd like to watch a very short video by one of the physicists that I like to kind of watch. Well, not really a physicist, but a scientist. And this one's titled, "What is a Force?"
What is a force? Seems to be an idea that a lot of people are confused about. Like Star Wars is the only source of knowledge. What is a force?
It's like Jedi.
Like force is how you raise X-wings out of swamps. You just concentrate.
What would you say a force is?
Other than Jedis.
But outside of Star Wars, a force is energy and mass. So if you have a huge thing moving really fast, you got a lot of force. It's like getting hit by a truck as opposed to getting hit by just tennis balls.
Force is energy that comes from somewhere.
Something that exerts energy on all other matter.
Movement. The movement of something in one direction and the atmosphere.
Listen.
I don't know. It's this indescribable thing that kind of keeps us from flying off into space. Nobody really knows what it's about. It's just a theoretical kind of thing.
That should teach me to interview philosophy students. But contrary to what she said, there were some people who knew what force was about.
Something that makes something move from its original position.
How you propel something, or how you get something to move, or how to reshape something. It's a kind of attraction or direction or something like that an object has on it. Yeah.
Push.
Yeah, push. Or a pull.
Sure. Yes. Okay, it took some coaching, but force is essentially just a push or a pull. So then I asked people, what forces are acting on you right now? Most could identify a downward gravitational force towards the center of the Earth, but then things got a little bit hazy. Can you tell me about the forces on you at the moment?
Well, probably there's a big force downwards towards the center of the Earth.
Which is?
That's gravity. Called gravity, I guess.
Well, the gravity of Earth.
Where is it? How does it act on you?
Well, it keeps me on the Earth. I don't fly away.
I would be standing on the Earth, and it's pulling me down and making sure that I'm stuck to the Earth. Yeah. Okay. What other forces are on you? Are there any other forces on you?
There are. There's air pressure forces around me. There's my own muscular forces keeping me up, my skeletal forces, those kind of things. And also then different sort of weather or climatic conditions.
In terms of what's like wind, weather, that sort of thing, or just normal gravity?
This is what's keeping me on the ground. It's not gravity.
So there's a gravitational force pulling you down.
Yeah.
Any other forces that are acting on you?
Friction.
Like on me right now?
On you right now.
I can't think of anything else except gravity.
Only one force.
Surely there's like a lot of small ones, but
Let me put this to you. If there's only one force on an object, what does it do?
it goes towards it.
But there is another force acting on you, which is a pretty important one. Because there's a force acting down, right? There's a gravitational force. What about a force acting up? No up forces?
Not that I can think of.
Okay, so what forces are acting on you right now?
All right, so hopefully all of you recognize that the average ordinary person probably doesn't understand that much about forces, which is partly why we go over some of this. So as you were watching this, hopefully I think you're starting to recognize preconceived notions that a lot of people think about forces and motion are maybe not entirely accurate, because obviously, as we've talked about, if the only force acting on you is gravity, then you should like keep on falling through the earth. So there is a normal force supporting you and pushing up against that force of gravity. So at this point in time, you're ready for the assessment on this section. And once you are done with that, you're going to be ready for the Chapter 2 test. So good luck on the assessment, and then you can kind of go back and look over things and get yourself prepared for the Chapter 2 test, ladies. Good luck.